Why is thermal imaging detection range often limited? Imagine trying to see through a foggy window with a flashlight. That's similar to what thermal imaging faces when environmental conditions aren't ideal. Thermal imaging devices detect infrared radiation emitted by objects, turning heat differences into images we can see. But many factors can cut down how far they can see. First, the type of infrared wavelength used by the device matters a lot. Devices working in the mid-wave infrared spectrum can see farther because their infrared light isn't absorbed as much by the atmosphere. Long-wave infrared devices tend to have shorter detection ranges because their signals get scattered or absorbed more easily. Next, weather and air conditions play a big role. Humidity, rain, fog, clouds, and pollution all absorb or scatter infrared radiation. When the air is humid or foggy, the heat signals weaken before reaching the camera. Even in clear weather, natural atmospheric absorption can limit how far the device can see. The size and heat contrast of the target also influence detection range. Larger objects that emit more heat are easier to spot from far away. Small or low-contrast objects blend into the background and become harder to detect at longer distances. For example, a person in a cold environment might be visible at a certain range, but a small animal with less heat contrast might not be. The resolution of the thermal imager is another key factor. Higher resolution sensors can pick up finer details and smaller temperature differences, allowing detection at longer distances. Lower resolution models might only tell you there's something there but won't give you clear details or identification. Detection range is often broken into three categories: detection, recognition, and identification. Detection is simply noticing a heat source. Recognition means you can tell what kind of object it is. Identification involves detailed analysis to confirm the specific type of object. These ranges depend on the sensor's optics and how many pixels cover the target. From a tactical standpoint, understanding these limits helps in choosing the right thermal device for the job. For long-range observation in clear weather, a high-resolution mid-wave infrared thermal scope is best. But in challenging environments with fog or rain, you might need a device with specific features or shorter effective range. In summary, atmospheric conditions, infrared wavelength, target size, sensor resolution, and the purpose of detection all limit how far thermal imaging can see. Knowing these factors helps operators pick the right tool for their mission and get the best possible results in the field.